Hello, ladies and gentlemen, and welcome back. We're going to be starting B part on our 2014 Canadian Open paper, so we'll be looking at B1 in this video. The area of the circle that passes through the points 1, 1, 1, 7, and 9, 1 can be expressed as k pi. What is the value of k? Okay, so we need a circle that passes through these points here. Well, how can we figure that out? I think there's probably a couple ways. One thing you could do is sort of, you don't have to plot the points, but you could sort of plot the points here. And 1, 9. And you could figure out sort of lines connecting them and get slopes of these lines, and the perpendicular bisectors will meet at the center. That's a perfectly fine way to do the question. Of course, you might know that all circles look like this, where r is the radius and h and k are the coordinates of the center. So you could set up three different equations using these points and try and figure out what h, k, and r are. Okay, don't confuse this k with the k in their answer. But I think the easiest way to do the question, now that I've actually plotted these points, is the following observation. So we know our circle goes through 1, 7, and 1, 1, and the other one was 9, 1. All right, let's just make sure we got those points correct. Yeah, 9, 1, 1, 7. And the ones that are here are really giving us sort of a big hint. And it looks like I'm drawing the triangle to do the perpendicular bisector sort of thing. This is not what I'm doing. What I'm doing is pointing out that, hey, there's a right angle. And we've got 2 points over here. If we connect up this hypotenuse and imagine our circle, well, if a chord and a third point make a right angle at that third point, then the chord is a diameter. So this is a nice diameter for the circle. And if you make that observation, which by no means is obvious unless you know some circle geometry, and I do always recommend you know circle geometry, even though you get less and less and less of that sort of thing in high school nowadays. But circle geometry makes this much easier. I'm not figuring out slopes and perpendicular bisectors. I'm not plugging things into the generic circle formula, although I could do the question if I didn't know these sorts of things. That's perfectly fine. But when we make this observation that, oh, if I've got a section of a circle and I can put a right angle triangle there, the hypotenuse of that right angle triangle must be a diameter. Nice circle fact, then suddenly this question is blown wide open. I can figure out the center of my circle. Okay, the center of the circle is just going to be the midpoint of the diameter. So how do we figure out midpoint? Well, you add up and average the x coordinates and average the y coordinates. We'll get 10 over 2, which is 5, and 8 over 2, which is 4. And now suppose I wanted something like the radius. Because how do I figure out the area of the circle? Well, you figure out the radius. And so if we have 5, 4 here, and 1, 1 here, we'll get a nice little right angle triangle, and the height here is going to be 4 minus 1, which is 3. And then we'll have a 4 over here. 3, 4, 5 triangle will have a hypotenuse of 5. Of course, if you don't believe me, you can do 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 is 25. So this radius is 5. And then, okay, what do we want? We want k pi is equal to the area. And area is pi r squared. That's pi times 5 squared, or pi times 25. And so k is going to be 25. And there we go. And if we had tried one of the other methods, we would get the answer, but we'd probably still be plugging in and rearranging equations and things like that. So circle geometry really comes in for the rescue here. So we've got the area, and we have our value of k, and if we want to, we can put it in the final answer position. Okay? But we're going to move right along now to question B2. I will see you for that in the next video. Thanks for watching.